Alright, we're going to continue with the question number 4. The A part says that we should determine the continuity or otherwise of the function. And you have the function, the way we're given two different, cases. The first case is that x squared minus 5x plus 6 divided by x squared minus 4, where x is not equal to 2. So x is not going to be 2, because if you put x as 2, you're going to get an undefined function. And then the next part is minus x squared over 16, where x is equal to 2. Now, just to keep this simple, what's the condition needed to show that a function is continuous? So let's say that a function f of s is continuous. Now, this is just the general rule. Continuous at any point. In this case, now you see that the point we are looking at is 2, and in the second question, the point we are looking at is 4. So there must be a point where you're going to test your continuity. So let me say that at a point A, and only if, right, let me just look for the mathematical jargon. If and only if f of x is equal to the limits as s approaches that A of f of x. So this is the condition. If f of x exists and the limit as s approach A exists, if they are equal, so if f of s is equal to the limit as s approaches that point of f of x, then the function is continuous at that point, which in this case at A. So the key there is that if you're given this type of question, where they ask you that, or rather where you were told that x is not equal, you're not going to take the limit, and where x is equal, you just have to use direct substitution, and then you're going to get your value. Alright, so we're going to, let me just draw a line. So I'm going to have, what's f of x first? So I can say f of 2, right? Taking from this the function at the bottom part, right? Because that's where I can do my direct integration. F of 2 is going to be minus 2 squared over 16, which is minus 4 over 16, right? Which is equal to 4 can cancel, we have minus 1 over 4. So f of 2 is giving us minus 1 over 4. Now, let's now test the limits. So we'll keep that one side. Let's now test the limits as s approaches 2 of the function. That's the upper limit. Now I'm going to take this one, which is s squared minus 5x. S squared minus 5x plus 6 divided by s squared minus 4. Okay, now if you do direct substitution, notice that this will be 2 squared, which will be 4, and 4 minus 4 is 0. So we cannot do direct substitution here. The numerator is a quadratic equation, so I think we can factorize, right? So we're going to use factorization method. If you factorize the numerator, you're going to have 2 times 3 is 6. Okay, so since we have minus 5, so let's go with minus 2 minus 3. So we're going to have x minus 3, x minus 2. Again, I just factorize this quadratic equation. That's why I said that if you want to be comfortable with limits, functions, and all this, you need to be familiar with factorization expansion. Again, I've done a teaching on factorization where I've thought about the major factorization techniques. So look for that in my video, the factorization techniques. You're going to see things like this, and it's going to be helpful to you. And then in the denominator, again, I'm seeing difference of 2 squares, right? Because I can rewrite this to be s squared minus 2 squared, and this is difference of 2 squares. So if you factorize, you're going to get s plus 2 multiplied by x minus 2. This is difference of 2 squares. That's how it is factorized. Okay, now you see that we can clearly cancel s minus 2 because we have x minus 2 there. So we're going to have, I'm assuming everything is still on one line, so I have x minus 3 over x plus 2. Now I can allow s go to 2. If I allow s go to 2, I'm not going to have 2 minus 3 divided by 2 plus 2. 2 minus 3 is minus 1. 2 plus 2 is 4. And we have minus 1 over 4 again. Notice that we have minus 1 over 4 when we took the limit as s approaches 2 from the first function. And when we put f of 2 in the second function, you see we're having the same value. Okay, we're having the same minus 1 over 4. We can now say since f of 2 is equal to the limit as s approaches 2 of f of x. Okay. Okay, let me change this from f of 2. Let me write it as f of x rather. Okay, f of s, right, is equal to the limit as s approaches 2 of f of x. We can now say that therefore the function is continuous. It continues at s equal to 2. Okay, so you can always rewind this video to make sure you understand the concepts before you go over to the next one. All right, let's go to the next one. All right, for the next one, you want to show that this function is continuous at x equal to 4. So you know the relation, right? You know the condition. F of x must be equal to the limit as s approaches 4, since that's the point we're interested in, of f of x. Okay, so now let's do f of 4. Okay, let's do f of 4, right? So it means wherever we see x, we're going to plug in 4. So 4 squared minus 3 into 4 plus 2. What do we get? 4 squared is 16. 3 times 4 is 12 and 2. Minus 12 plus 2 is minus 10, and 16 minus 10 is just 6. So f of 4 is giving us 6. And if we do the limit, so this one is one side. If we do the limit, as s approaches 4 of f of x, notice that we can do direct substitution here. We're still going to get 6 because we've already done that. It's the same thing we're going to do. Okay, so we're still going to get the same 6. All right, so this one is very easy to verify. So when we do f of 4, we have 6, and if we allow the limit as s tends to 4, we still have 6. So we can just conclude. Right? I like this type of question. Students like it. So we can say since f of 4 is equal to the limit as s tends to 4 of f of x, we can now say